The difference between factoring and solve by factoring is that our problem now equals 0, okay? And it has to equal 0 in order for this to work. So what we're going to do first is factor out, in this case, a GCF like normal. So I'm seeing that they have an x in common. And then left over, if I do that, x squared divided by x is x. Negative 14x divided by x is just negative 14. But it still equals 0. Okay? So we have to set each of these kind of two parts equal to 0. We have the x out here, and then the x minus 14. So I'm going to say x equals 0, and x minus 14 equals 0. Because if x was 0, 0 times this whole part in here, the answer would be 0 and it'd be true. That's what we want. Also, if this thing equals 0, then x times 0 would equal 0 and it would still be true. So let's just solve really quick. This one is already solved. You can circle it. This one, we have to add 14 to both sides. And x equals 14. Solved by factoring. All right, here's a trinomial that is set equal to 0, and it's asking us to solve by factoring. All right, so we're going to take our a, b, and c like normal. In this case, our a is going to be 1, b is negative 22, and c is positive 21. Okay, if I fill out my graphic organizer x, we're going to have a times c, which is 21, or b is negative 22, and two numbers that would work is going to be 21 and 1, and they both have to be negative. Negative 21 times negative 1 is a positive 21, and negative 21 plus negative 1 is a negative 22. Okay, but it still equals 0, so we have to solve by factoring. So I'm going to write my two parentheses here, and I'm going to say equal to 0. All right, now I can split my a term x and x. I don't need the brackets because it's just going to be a fill-in since a equals 1, and I'm going to fill in negative 21 and negative 1. I have to set each of these two parentheses equal to 0, okay? So I'm going to say x minus 21 equals 0, and x minus 1 equals 0. And it's just a matter of solving. Add 21 to this one on both sides. X equals 21. And add 1 on both sides here, x equals 1. So you have two answers, x equals 21 and x equals 1. All right, this next problem says solve by factoring. Again, it's set equal to 0, but our a term is prime. In fact, our a, b, c's are 2, negative 9, negative 18. All right, 2, negative 9, negative 18. So let's go right ahead. Since there's no GCF, we're going to jump into a times c, which is negative 36. Our b is going to be negative 9. And then let's see, two numbers that work. I'm not sure. Let's write them out. So factors of 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, 6 and 6. Okay, so ones that are 9 apart look like 3 and 12. So if I have a 3 and a 12 there, I'd have to make the 12 negative, in order for that, when I multiply, I get negative 36, and when I add, I get a negative 9. Okay, so I cannot use the fill-in method because my a term here is a 2. So if I split the 2x squared as 2x and x, we're going to have to use the bracket method. I'm seeing that 2 goes into the negative 12. So on that bracket, I'm going to put a negative 12. On the other one, I put a 3 from the two numbers that I found in my graphic organizer. And 2 goes into negative 12 negative 6 times. 1 in front of the x goes into 3 times. Now I'm not done yet though because it still equals 0. All right. So you have to set each of these two parts equal to 0. We're going to have 2x plus 3 equals 0. And x minus 6 equals 0. So this first one, I have to do a couple steps. I'm going to subtract by 3 on both sides. I have 2x equals negative 3. And then divide by 2. 2's cancel, x equals negative 3 halves. Oops, negative 3 halves. So you get kind of a fraction there, but that's okay. This one's a little bit easier. Yeah, just add 6 to both sides, and then x equals a positive 6. So your answers are -3/2 and 6.